When you are given a quadratic function, the first thing that we have to make sure is that we turn this into a one-to-one function by using a restriction. If you're not provided with a restriction, you have to come up with one that would make it, or at least turn it into a one-to-one function by using that restriction. On this one, we're already given one, and it is asking us to use the values that are greater than or equal to -2. So the domain is only going to consider values that go from -2 to infinity, including the -2. That's why we're using the bracket. And the range is going to consider values that go from -1 to infinity. And that's because this is a U-shaped function shifted 2 units to the left and 1 unit down. So we have the function down here going kind of like that. That's the function without a restriction. That's a rough sketch of the function. But because we're being asked to use values that are greater than or equal to -2, that means that we're going to go from -2 to infinity. Everything else that's to the left of -2 has to be gone. So that's the side of the graph we're using because of the given restriction. And now, because of that restriction, we're turning this into a one-to-one function. Now let's find the inverse function. We're gonna have y is equal to x plus 2 squared minus 1. We're gonna try to solve for x. So y plus 1 is equal to x plus 2 squared. Now we're gonna need to find the square root of the expressions on both sides of the equation. But just consider that if you're dealing with a quadratic, you're going to have two options, the positive option and the negative option. Because when dealing with a quadratic, when you square a number, squaring that number, even if it is negative, it'll turn positive. So you need to consider both. At the end, we're going to stick with the positive, but for now, we have to consider them both. So y plus 1 is equal to x plus 2. And then just solve for x. It's going to be plus minus the square root of y plus 1 minus 2. That should be equal to x. And now let's just write it as x plus 1 minus 2. That's going to be equal to y. We're going to write down the domain and the range. So if the range on the original function is that one right here, that's going to become our domain on the inverse function. I'm going to write the final answer of the inverse function in just a moment, and this is going to be the range. If we use a negative, that is going to mean that we're going to reflect the graph. We're going to have a reflection of the graph, and when we have a reflection, the range should go from minus infinity to that value. So that's why we need to use a positive sign, and we're going to have the square root of x plus 1, and the minus 2 has to be outside of the radical, outside of the square root. So if we sketch this function, it's going to be shifted 1 unit to the left. I'm going to use red, 1 unit to the left and 2 units down. And it's going to go kind of like that. If we had decided to go with the negative, the graph would have looked like that. And that doesn't quite make sense with either the reflection of the graph over this line over the line y, imaginary line y is equal x, it wouldn't make sense. And it wouldn't make sense with the range of the function, because the range is going from -2, over here -2, to plus infinity, not from minus infinity to -2. But right now we're gonna just use positive answers. We're not gonna deal with negative answers, but be aware that it is always a possibility if the range of the inverse function or the domain of the original function is using an interval going from minus infinity to the given value. But that's not gonna be the case, but just be aware that in the future it can happen. For now, we're just gonna stick with positive. You're gonna do it in the usual way, but right now, because you're going from a quadratic into a square root, you are gonna need to get the square root of both sides in order to find the inverse function. And that is basically